Pfeiffer from the Cleveland Fed will be today's moderator. Damian?
Thank you, Rafael. Also, hi everyone. The topics of today's sessions are: why do workers dislike inflation, wage erosion and conflict costs, and markups and inflation in oligopolistic markets, evidence from wholesale price data. Special thanks to the organizers, Rafael Schonle from Brandeis University and Dominic Smith from US Bureau of Labor Statistics. Some housekeeping rules at the beginning. The webinar is 45 minutes in total. We have two presentations of approximately 15 minutes each, and then at the end we'll have 10 to 15 minutes for Q&A. Attendees do not have the option to switch on their audio or video, but they are invited to write comments or questions in the Q&A space. Attendees can, of course, pose their questions during the presentations already, and do not have to wait until the end. The moderator will then select questions to be answered in the Q&A portion of the webinar, and that is after the presentations. The webinar is also live streamed via the CIBRA YouTube channel, recorded and made available on the CIBRA website and CIBRA YouTube channel after the event. Before we start, I also have to point out the disclaimer. Participation in a CIBRA webinar does not constitute or imply an endorsement, recommendation, or favoring endorsement of the views, opinions, products, or services of the Central Bank Research Association or any other participating institution, individual, or entity. All views expressed during a CIBRA or CIBRA co-hosted event are strictly those of the authors, discussants, and other participants, and not those of CIBRA, the co-sponsoring institutions, or any other participating institutions. Before we start, I would like to introduce today's speakers. The first speaker will be Chen Lian, who's an assistant professor at UC Berkeley, and he will be talking about why do workers dislike inflation, wage erosion, and conflict cost. And then the second presentation will be by Oleksiy Kryvtsov, who is a senior research officer at the Bank of Canada, and he will be talking about markups and inflation in oligopolistic markets, evidence from wholesale price data. So, without further ado, let's start. Chen, you have 15 minutes.
Thank you so much for the invitation. So this is joint work with Joao Vieira at UCLA, Jonathan Hazel at LSE, and Christina Peterson at Chicago Booth. And so in this paper, we ask the question, why do workers dislike inflation? The channel focused by the previous work is because prices rise faster than the wages. The relevance of this channel depends on how fast the nominal wages keep up with prices, which is how fast the real wages recover. But for example, in the recent pandemic inflation, the real wages recover actually pretty quickly. But still, workers seem to dislike inflation based on, for example, Stephanie Stancheva's survey. So instead, in this paper, we want to argue that workers must take costly actions, which we call conflict, to have wages keep up with prices. So there can be substantial welfare cost of inflation, even if the real wages do not fall during inflationary episodes. So we'll start with a motivating survey that will show that workers get wage growth through costly conflict with firms. This type of costly conflict includes tough conversations with employers, union strike, and soliciting offers from other firms. Then we will introduce this type of costly conflict in a model of wage setting, which we call conflict cost model. So this is effectively the manual cost model for the price setting, but you apply it for the wage setting. In particular, in this model, the firm's going to offer a default wage offer that's not perfectly indexed with inflation, and then the workers consider costly conflict with firms to raise nominal wage to keep up with inflation. We'll start with some analytical results. So in particular, wage catch-up after inflation from more frequent conflict does not raise welfare. And the intuition is the envelope theorem type of argument, is that because of the worker optimality, on the margin, the benefits of wage catch-up are going to be offsets by the cost of the conflict. So that's why the wage catch-up from those additional costly conflict actually do not raise welfare. Then the impact of inflation shocks on worker welfare is determined by wage erosion, which we define as how inflation shocks lowers real wages if the conflict decisions do not change with inflation, because those additional conflict driven by the inflation actually do not increase welfare. As a result, the takeaway is the welfare cost of inflation in the labor market can be large even if the real wage is unaffected by inflation, if the real wages recovery comes from those costly conflict from the firms. So the key terms for the welfare are going to be the size of the conflict cost and the degree of inflation indexation in the default wages. And so our survey has some additional questions that try to quantify this conflict cost model. For example, in the survey, we use kind of this indifference curve elicitation approach in experimental economics to elicit the conflict cost. And we show that workers are willing to sacrifice 1.75% of their wages to avoid a conflict. And there is also not much indexation. A 1 percentage point increase in inflation is effectively associated with 0 nominal wage growth absent of the conflict. And we use those numbers to calibrate the model for the post-pandemic inflation, and we find the cost of inflation incorporating conflict more than double the cost while falling real wages alone. So we'll start with the motivating evidence. We use a survey company called Prolific. It has 3,000 prime age employed US workers. It's run in early 2024. And it is representative of the general population in terms of a few chosen observable characteristics, such as gender, education, and political affiliation. And the survey has 2 parts. One is some qualitative evidence to motivate the model, which will show that the workers indeed achieve wage growth through costly conflict with employers. And the second part is quantitative evidence to further discipline the model. So I will start with the motivating evidence. So because we have a very short talk, I will just briefly summarize here. So we find kind of the following 3 kind of key motivating evidence that motivates us to write the model. So first, that many workers took costly actions to achieve higher wage growth than offered by their employers. And those costly actions include tough conversations with employers, union strike, and soliciting offers from other institutions or other firms. And the second fact is that those costly actions, which we call conflicts, indeed seem to lead to higher wages. For example, the workers who took these costly actions believe their wage growth would have otherwise been 3% lower. On the other hand, workers who didn't conflict believe conflict would have raised their wages by the 2%. Third, inflation leads to conflict. 1 percentage point in inflation is associated with 1.5 percentage point increase in the probability of worker conflict. This is true both in the survey through a hypothetical question, but it can also be shown in real world. We actually show that the probability of a union strike is associated with higher inflation in OECD countries. And so all those facts motivates us include all those kind of ingredients into a manual cost style model of wage setting, in which the default wage offered by the firm is not perfectly indexed with inflation, and workers optimally choose whether to conflict to raise their wage. So here is our model. So there is a continuum of workers balances the benefit of wage catch-up and the cost of the conflict. And kappa here captures the cost of conflict, and I captures whether the workers take the costly actions to increase their pay or not. So I equal to 1 means costly conflict, and I equal to 0 means not. And so in the talk, I'll do hand-to-mouth case, which is the consumption is equal to the wage, but in the paper, we'll also talk about the general borrowing constraint case. And the cost of conflict takes the standard, like so-called Cavo plus, seen in the manual cost model. So here means with the probability 1 minus lambda, the workers need to pay a fixed cost of kappa in the utility terms to conflict to raise their wage. and with probability lambda, which is the free adjustment probability, they can get a free wage increase. So we view this conflict cost as a reduced form cost, capture a variety of the conflict actions mentioned before. So here is the dynamics of the real wage. Without conflict, so there is a default wage offered by the firms, but it is not perfect index with inflation. So gamma here captures the degree of indexation, and only if gamma equal to 1, let's say that inflation do not lower the real wage. As long as gamma is smaller than 1 and inflation will lower the real wage in the default offer because of the partial indexation, and alpha are going to capture the default nominal wage without inflation. And if the worker conflict and the I is equal to 1, then the wage is going to catch up with inflation. The worker will get what we call a conflict-induced wage, which is a W star, which perfectly keeps up with inflation and productivity. And here the GZ is going to capture the trend productivity growth, and the IT is idiosyncratic productivity shock. So we're going to start with a steady state inflation. Actually, in the calibration, going to be 2%. And we're going to study the impact of one-time unexpected inflation shock and perfect foresight after that. And we're going to relax the perfect foresight assumption in the quantitative analysis. We're going to study its impact on aggregate worker welfare, which we have a utilitarian worker welfare. Sorry, and we connect it with the aggregate log real wage. So we start with a kind of simple observation in the model. In the model, an increase in inflation at period 0 leads to more conflict at period 0. I mean, the intuition is simple. When there's more inflation, because the default wage offer is not perfectly indexed, so there's more incentive for the workers to conflict. But this shows kind of the state dependency of the model, in which the likelihood of conflict increases with inflation, which both motivates our manual cost style approach and is also consistent with the empirical evidence how inflation increases with conflict. So our key objective is to connect the impact of inflation on worker welfare with the real wages. And so for this context, for this objective, we decompose the impact of inflation shocks on aggregate real wage into two components. One is the wage erosion, which is the impact of inflation shocks holding the conflict decision at the steady state. So the way we define it is basically we write down the wage as a path of inflation, conflict choices, and idiosyncratic conditions. But when we define this wage erosion, is the impact of inflation on the worker wages as if the conflict decision is at the steady state level. So you can see the I, the conflict decision here, is always SS, which means the steady state. And then the second term is the wage catch-up, which is the impact of inflation through the changes in the conflict decision. You can see here is basically the difference from actual conflict decisions and steady state conflict decisions. And we're going to show that the wage catch-up, because of the envelope theorem type of argument, is not welfare relevant, and the impact of inflation shocks on worker welfare is going to be captured by the wage erosion. So here's the results. The first order impact of inflation shocks on worker welfare is given by the wage erosion, and the reason is because the benefits of the wage catch-up are offset by the cost of the conflict. And specifically, we use the Milgram-Siegel envelope theorem applied to discrete choice set, because here the conflict decision is discrete. So basically, just because kind of the envelope theorem intuition, the benefits of the catch-up are offset by the cost of conflict. So that's why the impact of worker welfare is equal to the net present value of the wage erosion. And because we know by definition, the wage erosion is equal to the real wage response minus the wage catch-up. So we know the real wage response is not like a sufficient statistics about the impact of inflation shocks on the worker welfare. So the impact of inflation shock on the aggregate welfare does not, on aggregate wage does not perfectly measure welfare. Even if the real wage do not really move much, it could be because the recovery of the real wage comes from costly conflict, because of the wage catch-up actually comes from the costly conflict. That's why, you know, the wage response is not a good kind of sufficient statistics for the impact of the worker welfare. And it is sufficient for the worker welfare only in the pure time-dependent model, in which can be nested if the cost of conflict is infinite. But because in our model, we allow this manual cost style conflict, and that is why this is a poor sufficient statistics for the impact of inflation on the worker welfare. And we extend these results in the paper to a lot of general settings like general distribution, Rotenberg cost, more complicated conflict-induced wages, other aggregate shocks, unemployment beyond Hampton-Ross. So now we want to quantify the cost of conflict and then study the cost of inflation in the recent episodes. So the key parameter for the welfare is the conflict cost and the degree of indexation in the default wage. So our survey have the second part, which have some additional questions, try to elicit those conflict costs. So we'll start with conflict costs. So we will elicit this through kind of an indifference curve elicitation approach in the experimental approach, in the experimental economics. We first elicit the nominal wage growth the workers believe they can achieve via costly actions. So basically we just ask, in the next 12 months, if you can use one of those costly actions to increase the pay, what's the percentage of the nominal wage growth the workers think they can get? So for example, the workers can answer 4%. So it's like after conflict, they think they can get 4% of the wage growth. Then we will try to elicit the nominal wage growth where the workers are indifferent between accepting if offered by the employers and conflict and taking the costly action. And the difference between the conflict wage growth and the indifference wage growth between conflict and non-conflict gonna lead to the cost of conflict. In particular, the fraction of the wage that the workers would sacrifice to avoid conflict. And this can be directly linked with the conflict cost cutoff. And so in particular, we use this so-called multiple price list approach in experimental economics. So basically, if the respondents mentioned that if they conflict, they can get 4%, then we're gonna offer you a list of options, which is if employers offer you 4%, 3.5%, 3%, 2.5%, and see when you kind of accept those default offer and when you conflict. So if the workers never engage the conflict and they always accept the employer's default wage offer, so this means the worker have a very high conflict cost and do not really want to conflict. On the other hand, if the workers always conflict, that means this worker has a zero conflict cost. And so that's why they always try to do those costly actions to increase their wage. But in the more standard case, you can see the workers' choice gonna switch. So for example, they may choose to just accept the employer's offer at 2.5%, but they may conflict at 2%. So this can bounce the conflict cost between 1.5% and 2%, and we're gonna just take the median of the interval 1.75% as our calibration of the conflict cost. So here's the elicitation results. So the median of the conflict cost is 1.5% of the wage, which means the workers are willing to sacrifice 1.75% of their wage to avoid conflict. And then we also remember the model has this free adjustment probability lambda, and we calibrate that based on kind of the fraction of the workers who always conflict and has the conflict cost of 0 here. And then, so we also validate that this conflict cost in these hypothetical scenarios is indeed useful. So this elicitation seems to be, at least reveals a lot of information. For example, lower conflict in this elicitation indeed predicts a higher likelihood of taking actions in 2023 in the earlier part of our survey. And then the second part of the elicitation is about how the default wage offer changes after inflation absent of the conflict. So we consider hypothetical scenarios in which the inflation is expected to be X% in the next 12 months. And then we ask what the workers perceive the wage growth in their default wage offer from the firms. And the default wage growth do not really increase much with inflation, so that's why the degree of calibration the degree of indexation in the survey seems to be pretty low. So based on, for example, based on the evidence, the degree of indexation is only 5% because 1% increase in inflation is associated with only 0.05% increase in the default nominal wage growth. So now we will use those numbers into kind of our model, and then we use the standard parameters for the rest of the model, and then we can basically investigate the impact of inflation shocks on worker welfare. So here we solve the first order response to inflation shocks using sequential space Jacobian developed by Ockler, Bardossi, Rogney, and Straub. And then we evaluate the welfare cost of inflation shocks to worker welfare, and we decompose those into two components. Remember that the welfare impact of inflation shock on worker welfare is the wage erosion, and in particular has two components. One is the aggregate wage response, but the aggregate wage response is after the costly wage catch-up, which is not welfare relevant. So you need to minus the wage catch-up, which is equal to the cost of conflict because of the envelope theorem. So in total, the cost of inflation shock to worker welfare has two components. One is the aggregate wage response, but that is a little bit like not high enough because we also need to minus the wage catch-up term, which is equal to the aggregate cost of inflation due to the conflict. And so in particular, we consider transitory inflation, persistent inflation, and the 21-23 inflation experiences, which we just fit in the PCE inflation series into the model. And we consider both perfect foresights or inflation expectations we back out from the survey data. So in particular, across all the scenarios, no matter whether it's transitory inflation, persistent inflation, 21-23 inflation with perfect foresights or observed inflation expectation, we can show that the aggregate cost of inflation due to conflict is always more than double the cost while falling real wages alone. So neglecting the cost of conflict gonna severely underestimate the cost of inflation shocks to worker welfare. So the cost of inflation incorporating conflict gonna more than double the cost while falling real wages alone. So to conclude, workers incur this conflict cost to have nominal wages keep up with inflation. And our survey showed that the workers are willing to sacrifice a significant proportion of their wage to avoid costly conflicts. And we capture conflict costs in a manual cost style model applied to wage setting. And we show that incorporating conflict costs more than doubles the cost of inflation to the workers. And this is also part of a broader agenda, which is try to provide a tractable approach to introduce state-dependent wage setting. And for example, in progress, we think about the firm's cost of adjusting wage downward, because here we talk about inflationary episodes, the cost is from the worker side. But if in a recession, the relevant cost is workers want to needs to pay a cost to lower the wages. And because those costs is large, the firms don't really want to lower the wage, and that provides a model of, for example, downward wage rigidity. Okay, thank you very much.
Thank you, Chen. Alexei, you have 15 minutes.
All right. Thanks very much. Can you hear me? Damian, can you hear me?
Yes, we can hear you.
Okay, great. Yeah, so thanks very much for giving us a chance to present at this webinar. Thanks to Damian for starting his new role. This is fantastic news. So this paper is with my colleagues at the bank, Lou, Pat, and Ben. Lou and Pat are on this call. The views are our own. Now we ask, how does market power influence transmission of monetary policy shocks and inflation dynamics? Of course, there's plenty of recent evidence that shows that markets become more concentrated. Given this evidence, there's been recent theoretical work that pointed out that there is important interaction between firms' market power and even broadly market power in products markets and labor market. And on the other hand, with nominal rigidity. And these studies show that there's stronger monetary policy non-neutrality due to pricing complementarities arising from market power in these markets. Now, there's gap in the literature on the empirical side because the data, to find the data and methods that support this theoretical evidence is challenging. There's a few recent papers, including Raphael's paper with our that show that there is this relationship, but at longer frequencies because they use flexible prices. So data at annual frequency is not quite adequate for answering how market power interacts with nominal rigidity, because nominal rigidity is important at higher frequencies, less than 1 year. And that's what we're going to do in this paper. We're going to address this gap by studying the interaction of market power with nominal rigidity using microdata. Here's what our paper does. We offer sort of 3 types of contributions. First, we work with a model with oligopolistic competition, sticky prices a la Calvo, and heterogeneous firms and heterogeneous sectors. The main part here is that this model allows us to derive a closed-form solution for how firms adjust their prices after cost shocks. The key is we're going to point out that depending on the nature of the shock, the pass-through to the price is different. If the shock is idiosyncratic to the firm, the pass-through is different from when the shock is common to all the firms within the industry. We're going to take this prediction of the model to microdata, and we use microdata for Canadian distributors. The advantage of this data will be that it offers very, very good proxy for marginal costs and markups, and it allows us to decompose the cost shocks to these distributors that are common or idiosyncratic. And this micro evidence provides very, very strong corroboration of predictions of the model. So once we have that corroboration, we're going to take it back to the model and ask, once the model is calibrated to this micro evidence, what is the prediction for sort of the usual key statistics related to the strengths of monetary policy? And we find that they're very important. If we abstract from heterogeneity across firms and sectors in a one-sector model, we get that market power implies the slope of the New Keynesian Phillips curve that is one-third less than in the standard model. Once we bring in the heterogeneity, the total decline in the slope is 2/3. So quite strong effects of market power once it's allowed to interact with nominal price rigidities. That's the main takeaway of the paper. So let me quickly go through all these three stages. So just to summarize the model, the key element of this model is that there's going to be sectors of distributors who are oligopolistically competitive. So there's finite number of distributing firms in each sector. And there is the upstream layer in each sector. So these distributors, they purchase products from their suppliers. Suppliers compete among themselves, monopolistically. So there's many of them. So distributors therefore take the price of the suppliers given, and then they sell this product downstream to consumers. So the distributor's cost, and distributor's cost is the price of the supplier, has common and idiosyncratic components. Common components is when the shock is common to all the firms within the sector, versus idiosyncratic, which is specific to this distributor. And as I said, sectors will also differ in terms of both market power and price stickiness. Now, the one key assumption here is that the price at which the distributor buys the product from the producer is sticky a la Calvo. It changes once in a while. And its price at which it sells this product to the consumer is also sticky a la Calvo. Now, the price changes for both upstream and downstream prices are perfectly synchronized. That's the assumption in the model. We show that it's very reasonable from the point of view of the data. Prices are highly synchronized in the data. And there's also previous work that showed this tendency between downstream and upstream prices to be highly synchronized in the literature already. This assumption of perfect synchronization buys us a lot analytically. We derive the key prediction of the model. And so this is an assumption that is key to our model. We make additional assumptions that help in our analytical work, and I'll skip them for the sake of time. So here's the key prediction of this model. On the left-hand side, it's the price, the reset price of the distributor. So when this distributor gets to adjust its price after a Calvo signal, The left-hand side is that reset price. The distributor is I in sector J in month T. That price is a function of two terms. So there is a common cost change. So this is the common price among all suppliers in this sector. So this is therefore a common cost for distributors in the sector. And it is idiosyncratic cost component. So it's the cost of this specific distributor relative to the average cost in this sector. And so the two terms have these two components, and these shocks have different pass-throughs according to this proposition. The left-hand side, the coefficient in front of the idiosyncratic cost is the idiosyncratic cost pass-through, and then on the right-hand side is the pass-through of the common cost. These two pass-throughs depend on two key parameters. One is the parameter that depends on the strength of the market power, and the other one, lambda, is the stickiness, the price stickiness is the probability of non-adjusting the price, okay? Now, the market power coefficient phi, it's specifically the elasticity with which the price is reset in response to the relative price change of this distributor relative to the average price. And it's proportional to the market share of this distributor. And under certain assumptions here, it's to Cournot, but findings are similar for Bertrand competition. It is also proportional to the markup of the distributor. This feature is very convenient in empirical work because we have very good proxy for the markup in the data. So let me quickly show you how these two pass-throughs depend as we vary price stickiness and market power. So first, I'm gonna fix market power at a certain level, and these are simulations of the model just to illustrate these functions for pass-through. I'm gonna vary pass-through from 0, which is perfect flexibility, to some degree of price stickiness. And the two pass-throughs are pictured here. So the brown one is the common cost pass-through, which is this coefficient in front of the common cost shock. And the green one is the idiosyncratic cost pass-through. So when prices are fully flexible, all firms will be adjusting. And so there's no relative price movement across adjusters. And so the firm is fully passing through the common cost change. Now, on the other hand, when only the distributor is hit by the shock, it means that my price will be moved away from prices of other firms. And because of market power, I have an incentive to not pass it through fully because I want to keep my price not too far away from prices of my competitors. And the pass-through of idiosyncratic cost is actually below 1. So that's the flexible price case, which was entertained in the literature by other papers, including AIK here. Now, what we do is we look at price stickiness that is not 0, right? And as you increase the price stickiness, the pass-through of the common shock goes down. And why is that? Is because now the firm is realizing that only some of the competitors will be adjusting. And those that do not adjust their prices will stay put. And so there will be relative price differences between my prices that I adjust and some of the other competitors. And so I have an incentive in that case to lower my pass-through of the common cost shock. And I will do that more the more concentrated the industry is. On the other hand, if I'm passing through idiosyncratic cost shock, I only care about average price of competitors, not so much how many of them are adjusting or not adjusting their price. And so this pass-through stays constant as price stickiness is increasing. Now I'm going to fix price stickiness at some number, and I'm going to increase market power. For flexible, for zero market power, so for the standard New Keynesian model here, there's, market power is practically 0. And so there's no strategic consideration here. And I'm going to pass through fully the shock, whatever is coming from common or idiosyncratic. But as market power is increasing, the considerations of competition and sort of keeping my price close to competitors become increasingly important. And so both pass-throughs go down. So these are the key predictions of the model. There are 6 of them. The slopes and also level at the flexible and here, and we're going to take these predictions of the model to the data. The data is for Canadian wholesale services. These are my monthly data going from 2013, and we ended at the pre-pandemic level. There's a lot of observations. We have many firm product combinations. The main feature of the data is already mentioned. For each distributor, we observe both the price at which it buys it from its supplier, the purchase price, and the selling price at which it sells it to downstream. Now, because distributors do not provide additional value added to the product, they just buy and sell it pretty much. The ratio of the two prices, selling price to purchase price, is a very good proxy for the markup, and that's what we're going to use in the empirical work. We're going to use a lot of observations here to our advantage to disentangle what common shock and idiosyncratic cost changes. The distribution of the market here is determined by classification either by industry, so we use 4-digit NAICS industries, or alternatively as product classification, which we do at 7-digit NAP CES codes. In the first step, we decompose changes in supplier prices into the common component and idiosyncratic component. The common component basically is the sector month fixed effect of the panel of prices of suppliers, and the residual is the idiosyncratic cost change. We're going to estimate those two cost components and use them as the regressors in the second stage. The second stage is basically the equivalent of the prediction of the model that I showed you before. So left-hand side is the change in the reset price level of the distributor, conditional on the price change, as a function of the shock, so these two terms here, with coefficients that are the common cost pass-through and idiosyncratic cost pass-through that are allowed to vary with degree of price stickiness in the sector, or the quartile, in this case, of the markup of the sector, with fixed effects and the residual. So this is the table with the main results. So first, I'll sort of to remind you, the model predictions for each of these 6 elements of pass-throughs are that the common cost for flexible prices is around 1. The slope is negative as we vary sector stickiness and sort of the degree of market power of the sector relative to other sectors. And for idiosyncratic shocks, it should be below 1 for flexible price sector, around 0 slope as we vary stickiness, and negative as we vary market power. It turns out that all these predictions are going to work out in the microdata. So the slope is 1 for flexible price sector, and slopes are negative as we vary price stickiness or market power. And when we go to idiosyncratic cost, for flexible price sector, the intercept is below 1 significantly. The slope is not varying as we vary price stickiness, and the slope is negative as we increase market power. So all 6 predictions work out in the microdata. So in the remaining couple of minutes, let me tell you why this matters. We calibrate the multi-sector model that we now can aggregate and derive the slope of the Phillips curve with market power that is calibrated to match this microdata. So going first, abstracting from heterogeneity and market power and price stickiness, you see that the slope is standard except for this additional factor that captures the degree of strategic complementarity here. The one that matches the data implies that the slope is going to be lower by about 30% from the standard Caldwell model with monopolistic competition, right? So that's already a sizable effect here. So I'm going to show you 2 more versions of this model. In the first version, we're going to add heterogeneity across sectors, only heterogeneity in price stickiness, keeping the same market power for each sector at this point. Once we add heterogeneity in price stickiness, the slope decreases even more by an additional 20%. Now, this effect for heterogeneity in price stickiness is familiar from previous literature. For example, in Carlos Carvalho's job market paper, he shows that theoretically this effect is there. And the reason is that after a monetary policy shock, the adjustments in terms of adjustments across sectors come predominantly for sectors with more flexible price adjustments. And so as time lapses after the initial shock, more and more unadjusted prices come from sectors that are stickier, right? So adjustments become increasingly slower, and that sort of adds the persistence in the price level adjustment. So here, then, we add to heterogeneity and price stickiness, heterogeneity and market power across sectors. Now, an important feature of the data is that the market power and price stickiness across sectors are positively correlated. More stickier sectors tend to be more concentrated. That heterogeneity and interaction adds the propagation. And the reason is that after the initial shock, not only price adjustment become increasingly slower, but because more stickier sectors are also more concentrated, price adjustments, in addition to being slower, are also smaller because of the strategic complementarity. And quantitatively, what it does is it decreases the slope of the New Keynesian Phillips curve by a total of 64%, and it doubles the monetary non-neutrality. So to conclude, let me just summarize the contribution of our paper. We, first of all, account for the effect of price stickiness on the pass-through at a higher frequency that have previously been studied. While doing that, we use the data that provide us with very reasonable proxy of the market power, which is usually a challenge in the data. The data allows us to look at two components of the cost shocks, and these components give us the statistics that we show are important for pinning down the interaction between market power and price stickiness, and the across and within sector variance in the data allows us to corroborate predictions of the model. And what it predicts at the macro level is that the effect on New Keynesian Phillips curve slope is actually quite sizable. Thanks, I'll stop here.
Thank you very much, Alexei. A few questions for both presenters. But before I go to questions, Chen or Alexei, do you have any questions for each other? Alexei, you have your hand raised.
Yes, I have two quick questions. They're very related. The kind of one for Chen, very interesting paper. One question I had was, so here you assume that the costs are borne out by employees, right? You know, if we thought of costly adjustment of price of these wages, right, it would be more natural probably to think about costs borne out by the firm as well, right? So then it would be interesting to kind of think about sort of the nature of this cost that could be borne out not just by employees but the firm as well, more generally. But the second part of this question is also, if I understand correctly, you're treating incumbent employees and employees coming from outside as the same from the point of view of the firm, right? But here, they must be very different, right? Because employees that are incumbent, they're sort of internalizing, paying their own costs to stay at the firm, whereas employees that come from outside, their costs are already kind of, they decided not to pay them and look for a job. And so the firm has an option to price discriminate across, you know, incumbent employees and employees that come from outside. So the cost of moving, in other words, must be very important here as well.
Great question. So the first, this paper focused more on the worker side, and so it's allowed actually to also the firm bears some part of the cost, but because we focus on the impact on the workers, the firm side cost is not directly relevant for the worker problem. But that said, we are writing a basically entire follow-up paper on the firm side. So there are lots of firm level things, like for example, the degree of indexation is fixed in our model, but then you may wonder why the firms do not perfectly just index those wages. And so there are a wide range of, you know, the firm side questions that's interesting, and we will explore more. And then the second part of the question is about the new workers and existing workers. So actually, in the general equilibrium model we have, which I don't have the time to talk today, actually the new workers, their wage automatically catch up with inflation. So the lack of indexation with inflation only applies to the existing workers, but the baseline model is kind of we don't really make a distinction between the new workers and the existing workers. But in the full general equilibrium model, this distinction actually is relevant.
Thanks.
Thank you. Chen, do you have any questions for Alexei at this stage?
So I wonder how to interpret the regression if there are manual costs instead of the curve adjustment.
Yeah, so we did it. We had a version of the model with menu costs because it's very difficult to implement. We did it for only duopolistic firms and sectors, and predictions in our simulations actually work out quite well as well. So it's more general. It's not just specific for the Calva setup.
Thank you. Some questions for the chat. There were quite a few questions very similar to the question that Alexei already asked. But perhaps one of them was, have you thought about optimal policy in this framework, Chen? What would be the optimal policy from a planner's point of view? And then the second question, perhaps if you can elaborate a little bit, if I can summarize a few questions, is perhaps can you tell us a little bit about heterogeneity of the results that you found in your survey? And there seemed to be quite a lot of heterogeneity, as you showed on your figure, with respect to the cost the firms perceive. Is there any particular demographic structure of these answers, like such as age dimension and so on?
So so I think to have a proper treatment for the optimal policy, we also need to figure out the firm side, further elaborate on the firm side. So actually our plan was to do the firm side first, and then we go to the policy. But one thing I do want to mention is that this conflict cost is actually not just a redistribution between the firms and the workers. This is because, you know, the aggregate cost of conflict can be viewed effectively as a deadweight loss. And for the second question about heterogeneity, so interestingly, so we do find lots of heterogeneity, but the heterogeneity is actually not correlated with the kind of standard demographic dimensions. So we actually we suspect there should be some heterogeneity of conflict costs with, for example, maybe income level, education, gender, but we actually do not find much correlation with, you know, those standard dimensions. So we would like to understand more about why, but in our current survey elicitation, there are lots of heterogeneities, but not correlated with standard dimensions.
Thank you. Perhaps one last question for Alexei. Can you elaborate a little bit on your synchronization assumption? You know, do you have any intuition what happens where prices are synchronized 3/4 of the time, but not always?
I don't remember if we might have run an exercise there, Rafael. I have to be honest. I don't remember right now. If we have, let me get back to you on that.
Okay. Otherwise, thank you very much to both presenters and to everyone who participated in this 20-second inflation drivers and dynamics webinar. We'll see you next week. Thank you.
Thank you so much.
Thanks very much. Thank you.
Thank you, everybody. Bye.